Hello everyone, welcome to this brand new math series, Surd. In this episode, we will uncover what a surd really means, why it's called irrational, and how to recognize it in your exam. So let's begin. We start with the definition of surd. See, a surd is a number that cannot be expressed as a simple fraction and whose square root cannot be exactly determined. We have example square root of 2, square root of 3, square root of 5, square root of 7, and so on. These are examples of a surd. The reason is, for instance, if you take square root of 2, if you use your calculator to press square root of 2, it will give a number that does not end. You have something like 4, 1, 4, 2, 1, 3, and so on. It goes to infinity without end. So these are examples of what irrational number. That means it does not have an end, it does not terminate, then it's not repeated decimal. You see that all these decimal number, none of the number is repeating itself, so it's not reoccurring. But if you have square root of 4, you observe that square root of 4 will give you 2. So it means this is what? Rational number. That means not a surd. So not surd. Because when we take the square root of 4, it gives us a whole number, an exact number. That means not a surd. So a surd simply means irrational number that cannot be simplified. That cannot be simplified. So and so on, so forth. Yeah. Now we have properties of what? Surd. We have what we call properties of surd. The first properties of surd are we have square root of PQ. Now when you see you have P and Q, the operation that join them together here is multiplication. So you can simply split them, which is going to be square root of P times square root of what? Q. So this is one of the properties. And again, if you have another one of this form, you have square root of P divided by Q. Now it means this line means division. If you have P as a numerator and there's division that separates them, so that the operation here is division. So we can split it to be square root of P over square root of Q. Then another one we have is if you have square root of P plus Q is not equal to square root of P plus what? Square root of what? Q. The reason is that if the operation that join the two letters together, these two letters is what? Addition, you cannot split them. So square root of P plus Q is not equal to square root of P plus square root of Q. Then again, you can have another one which is square root of P minus Q is not equal to square root of P minus square root of what? Q. You can't separate them. So this is one of the properties. When the operation is subtraction, you can't split both terms. So this is not equal to this. Then you have another one. If you have 2 root P, this can simply be written, if I write 2 raised to the power 2 like this, then multiply by what? Square root of what? P. Now if I cancel these 2 with the root, I will still get back to what? 2. So this can be written as what? 2 raised to the power 2 will give us 4. Then you put your P here. So when you have an expression in this form, it can be written as this. So you take the square of the constant time outside, that's multiplying the square root, you square it and you put it inside the square root. Then when you raise the 2 raised to the power 2, you have 4. Then the operation here is multiplication. I can join them together inside the bracket. Then let me add another one. if you have 3 root p is not equal to square root of 3p. It's not equal to square root of 3p. So these are properties of surd. Let's move to identify surd. So how do we identify surd? Which of these are surd? Now if you look at this, we have the first one, which is square root of 9. Now if I take the square root of 9, I'm going to have what? 3. So this is not surd. Not a surd. The reason is that it gives us a whole number. It terminates when you take the square root. So it's not a surd. B, you have square root of 7. Square root of 7 will still remain what? Square root of 7. When you take the square root of it, it gives us a decimal number which does not terminate. And it also does not repeat itself. The decimal number is not repeating. So this is what? A surd. Then we have C. We have cube root of 8. Cube root of 8, if you take the cube root of 8, it will definitely give you 2. Cube root means what number you can multiply together in 3 places. I will give you 8, which is 2 times 2 times 2 in 3 places. So it gives us a whole number. So this is not what? A surd. So far it gives us a whole number. It's not a surd. And lastly, we have square root of 11. Now square root of 11, definitely when you take the square root of this, it's going to give a number that is not repeating itself, it's not recurring, and it does not terminate. So square root of 11 is a surd. Is a what? A surd. So once you know what makes a root irrational, identifying surd become fun. Alright, so this is where we are going to stop for today's episode. Now you know what a surd is and how to identify one. In the next class, we will dive into simplification of surd, how to break them down into smaller forms. So don't miss it. Hit the like button, share this with a friend preparing for WAEC or NECO, and drop a comment in the comment section if you learned something today. Thank you.